Hello and welcome to Space Shark Teaches. I'm Sean, owner and lead developer of Space Shark Studios, and in this series we're going to be teaching Godot. In this lesson we are going to be starting to use jump, and part of that is going to be updating how we're using our physics. So to re-go over what we did last time, we moved a lot of our movement and gravity into their own functions. So as you can see, we have a speed. When we're going left, we have a negative speed, so it goes this way. When we move right, we have a positive speed. And when we have gravity, it goes down. So what you can't really see here as much is that if you move the platform to the bottom and your player all the way to the top, one, gravity doesn't really work like gravity. It's just moving down. And left and right just kind of go at their own speed. This would normally be fine, but let's look at adding jump. So the first thing we're going to do is move things around because we want gravity to come before everything else. And this is just because of the order of operations we're going to be going in. We want gravity to be applied, and then our movement and our jump. So we are going to make a new function called jump and a new variable called jump speed. Like normal, we need to edit the variable to make it an int. Let's go ahead and just set its initial value to 10 and turn export to on. So just like we've done before, we're going to add an action, a condition, and then all of this fun stuff. So the condition can go here. We use the available nodes to pull an action in, and we are going to use up, which is up on your arrow keys to check to see if we've jumped. Once we've pulled in the jump speed, we can make a new vector 2, and we are going to actually be pulling this into the Y slot because we are working just like with gravity on the Y vector. So now you can see in gravity we are increasing Y, which means it's going down. So in jump we have to negate, just like we've done before with the movement left and right. And when all of that is done, we can do, like normal, move and collide. Let's see what happens. Need to make sure jump speed is 10, so we're going to jump twice as fast. Oh, we need to do one thing that we forgot, and that is actually add it to this list, because otherwise it will not be called. So once we've added it, well, that's not right, is it? We only want to be able to jump when we're on the ground. And they have a function for that. However, isOnFloor only updates when calling move and slide. And this means that we're going to have to redo a lot of how our physics are done right now. And it's for good reason. So we're going to add, first off, isOnFloor. We can move all of this, and we're going to add another condition for isOnFloor. And as you can see right now, we're not going to be able to tell if they're on the floor because we're not using the correct function. We're using move and collide instead of move and slide. Now, this is where it gets complicated. Move and slide, if you go and search for move and slide, it actually uses the physics process instead of process, and it has a linear velocity because of that. So right now, move and collide, as you can see up here, it moves it a certain number of pixels every time it's called and stops if it hits something. Move and slide, however, will slide along the ground using a velocity. So a good example of this would be if someone told you take 5 steps forward, that would be move and collide. If someone says take 5 steps forward every minute, that would be velocity. And that's what we're dealing with here. Right now, because of how this is all set up, we are moving 5 steps based on this every time a frame is drawn. We don't want that. We want this physics process, which will run at a constant rate. If we continue using process, if you have a fast computer, you will move. So let's say you have a fast computer and you're running 100 frames a second. That means you're moving 5 steps 100 times a second. So you're moving 500 pixels a second. If you have a slow computer and it's running at 10 frames a second, you're going to be moving at 50 steps a second. Physics process will update regardless of the speed of your computer at the same rate, which means whether you're running at 10 frames a second or 100 frames a second, all of these calls are going to happen as they're supposed to. So we can select all of these, Control C to copy, Control V to paste, and hook them up. And then we can just go ahead and delete that old process. I right-clicked and click Remove Function. When you play, you can see this doesn't really change much. That's good. That's what we wanted. However, now we have to switch everything out from this move and collide to move and slide. And that's what we're going to be doing in the next episode or next lesson. That's it for this lesson. Thank you for watching, and this has been Sean with Space Shark Teaches.